start this lesson off with a little demo from mathopenreference.com, which is a pretty cool site if you want to check out some geometry and get a little maybe different visuals than you're getting in the videos. So this lesson is about transversal lines and the angles that they form when the lines are parallel. And in this diagram, we've got a transversal, this line AB right here, coming through those other two lines. These lines aren't parallel, but I want to just maybe drag them around till I can see that they are. Now look at that. You see these familiar little arrows? Again, that means that these are parallel lines. And so the transversal is crossing lines, but when they're parallel, something important happens to the angles. And let's check out the corresponding angles. I'm going to show you the details here. Look at these corresponding angles. This 39 degrees up here, and then it's twin down here. And literally it's a twin because it's matching 39 degrees. Does that happen when the lines aren't parallel? When I drag this around, you can see this angle, 49 degrees, and here it is at 39 degrees. Now these still correspond because they're in the same position, but when they have that parallel line relationship, not only do they correspond, but they're also congruent. Let's jump to the next set of corresponding angles. There's the 141, and it's matching corresponding angles 141. So this is showing us the corresponding angles postulate. Let's check out all of them around there. There's our next pair, 39 and 39. And 141. What happens though if I move the transversal so it doesn't come at the same angle? If I move that transversal around, notice that I get different angles, but they still match. Those corresponding angles still match. 27, 27. No matter how I move my transversal, I change that angle, but I don't change the fact that it matches its corresponding angle. So that is the corresponding angles postulate. Let's write it down. The corresponding angles postulate says that if we have two parallel lines that are cut through by a transversal, then each set or pair of corresponding angles are congruent, as we saw. Those are congruent. So in our picture, we could say that angle 2, let's mark it congruent to its corresponding angle, angle 5. And that works for all sets of corresponding angles. Let's take angle 1, for example. I have a dead pen. There we go. Angle 1 here. Angle 1 is going to be matching its corresponding angle, angle 6. Angle 8 is corresponding and congruent to angle 3. We'll just mark these in different ways. And last, angle 4, that one is corresponding and congruent to angle 7. So we could write any of those as a match. If we knew this angle 1 is, say, looks like maybe 65 degrees, then down here at angle 6, I know that's going to be 65 degrees. They're twins. All right, we have some similar theorems for our other types of angles. The alternate interior angles theorem says this. It starts out the same way. If two parallel lines, I'll use some symbols, are cut by a transversal, if two parallel lines are cut by a transversal, then the alternate interior angles, they are congruent. So our alternate interior angles, this angle 3 right here, angle 3 and its alternate interior angle, angle 6, those are going to be a match. And likewise, angle 4 is going to be a match with its alternate interior angle, angle 5. The alternate exterior angles theorem, that one's similar to the alternate interior angles theorem again. If we're going to have two lines parallel and they're cut by a transversal, let's just draw a picture of that. Cut by a transversal line, then the alternate exterior angles, those are the same also. Alternate exterior angles are congruent. So diagram that. Find a set of alternate exterior angles, like maybe angle 1, angle 1 and angle 8. Those would be congruent angles. On the other side, angle 2 is going to be congruent to its alternate exterior angle 7. All right, now same side or consecutive interior angles, those a little bit different. Let's identify them first of all. Angle 4 and angle 6. Now guys, these two angles, I'm not even going to do that in the same color because they are not congruent. I know they're not congruent right off because I know that angle 4 is obtuse and angle 6 is acute. So they're not congruent, but they do have a relationship still. That relationship is that they are supplementary. Remember, that means they add to 180. If I add those together, I'm going to get a 180 total. So the theorem reads this way. If two parallel lines are crossed through by a transversal, then the same side interior angles are supplementary. They have that 180 total. So what is angle 3 and angle 5 going to be? If I add them together, the measure of angle 3 plus the measure of angle 5. Well, angle 3 and angle 5 are on same side and interior. That, according to our theorem, is that they're going to be 180 total. And on the last one, our same side exterior angles. That's angle 1 on the exterior paired with angle 7 on the same side exterior. Not a match. Let me put double tick marks there and single there. Those are not the same size. Again, this is acute. This one's obtuse. But they do have a supplementary relationship. So the measure of angle 1 and add that to the measure of angle 7, you add them together, you're going to get 180 every time. Same holds for angle 2 added to angle 8. These two get added together, angle 2 and angle 8, 180 is the answer, or the total. So that's when we have parallel lines cut through by a transversal, then the same side exterior angles are supplementary. Example time. Got some hard ones for you, but I've got some easy ones to start you off. So these are the same kinds of problems that we're going to use to practice these ideas. On each one, before you make any conclusion about the measure of the angles, you need to check to see if you have the parallel lines. So these arrows right here telling me that these lines are running parallel is key information. Don't try to use these theorems and postulates if you don't know the lines are parallel, because as we saw in the demo, if the lines aren't parallel, then we don't know anything about the angles. They could go every which way. All right, but these are. So our question mark is here. We got to figure out this angle, and we have to justify our answer. Well, how does this angle relate to the given angle? We have 109 here, and we need to know this one. Those are alternate interior angles. And so I'm going to say that this is 109 degrees, and I'm going to justify that by the alternate interior angles theorem. So you are allowed to either write out that theorem, or you can just name the theorem. And this abbreviation right here is for theorem. Don't pronounce it thum. That's an abbreviation for theorem, alternate interior angles theorem. Since these are alternate interior angles, they have the same measure. Okay, example 2. Here's our question. Here's our given information. We have a 75-degree angle and we have parallel lines. So we're allowed to use one of our theorems or a postulate. What kind of angles are these? These are in the same exact position around the two vertices, one in the lower left corner, one in the lower left corner just as well. These are corresponding angles. According to the corresponding angles postulate, which is going to be my justification, the corresponding angles postulate says this is going to match this. So I'm just going to say this is 75 degrees. Not bad? Okay, here's the next one. Are the lines parallel before we do anything? Our double arrows say yes, they are. So since they're parallel, I can make a conclusion about angle 110 and this one right here. These are on the same side of the transversal and they're both interior. These are same side interior. We learned that these, no, they are not the same, but they add to 180. So 180 minus the 110 is going to give me that missing angle. That's a 70-degree angle. And that's 70 degrees because of the same side, these were interior, same side interior angles theorem. There's your abbreviation. Let's check out number 4. Now the first step is always to make sure you have the parallel lines. What if you don't have parallel lines and you're asked to find one of these? You should answer not enough information. You must have the parallel lines. Okay, so we've got a 98-degree angle here, and we're looking at a question right here. How are these related? Let's name them. First of all, their relationship is the same side on the transversal, but interior. These are same side interiors. So this is a lot like number 3. These add to 180. Same side interior angles are supplementary. That's the same side interior angles theorem. So what do I get if I take 180 and subtract out 98 degrees from there? If my arithmetic is right, I think that's 82 degrees. So 82 degrees is my answer. And I justify it with the same side interior angles theorem. Number 5, holy smokes, we've got 1, 2, 3 lines and they're all marked parallel. So yeah, you can have more than 2 parallel lines. You can have a whole bunch of parallel lines. You guys look at your notebook paper or even your note paper you're using right here, you got parallel lines on those columns. So we've got 3 parallel lines, but this is the angle we need. And we've got this extra line over here that I don't think has anything to do with the picture, since this is the transversal that I'm going to follow to get to a different angle. So if I follow this transversal up to this position, I see a 129 degree angle right here. And I want to compare that to this angle down here. So it looks like I don't even need to worry about this top line since none of the angles are even involved with it. You might just ignore that. How does the 129 relate to the one down here? Well, they're both obtuse. You might guess that this is 129, and you would be right about that. They do match since they're on the parallel lines, but what kind of angles are they? Those are both on the outside of the 2 lines I'm looking at. I'm going to call these alternate exterior angles, and I'm going to use the alternate exterior angles theorem to prove that that's 129 degrees. Our last example looks like we're going to tackle some algebra. We have handled these before. We can do it again. First step always, do you have parallel lines? If the answer is yes, then you can proceed, and we do. How do these 2 lines make these angles relate? Well, this is sort of like number 5. See how they're on the exterior of the 2 lines? They're alternate exterior. So I'm going to set up an equation that says that my 10x plus 15 angle is congruent to my 12x minus 3 angle. So 10x plus 15 is going to have the exact same value. It's going to be equal to, it's the same thing, as 12x minus 3. And that gets justified by the alternate exterior angle theorem. That's the theorem that allows me to set up this equation. So let's bring in the math ninjas. Let's get the x's alone. I'm going to say, since I've got my 12x's here, there's more on this right side than the left. So I'm going to, in the end, I'm going to want my x to be on the right, which means this 10x is in the wrong place. So I'm going to wipe it out with the negative 10x taken from both sides. And that brings this to 0. Those are killed off. Now I've got 15. And right here I'm down to 2 x's and my minus 3. So let's get rid of the 3. It's on the wrong side. Let's add a 3 on both sides here. That wipes the 3's out. Now I've got 2 x's, and 2 x's is the same as 18. So the final step is divide that 2 off so that I'm down to 1x. So 1x is equal to 9. X is 9. The question asks us to find both angle measures, so let's go put 9 into the angles. If I take 10 times 9, according to my little expression here, and then I add 15, what do we get? 10 times 9 is 90. 90 plus 15 brings it up to 105. That's 105 degrees. Now when I do it on this one, I take my 12 times 9, take away the 3, 12 times 9, that's 108. 108 minus 3 is 105. And I would not have expected anything else. I expect this to match this. They're both 105 since they're alternate exterior angles on the parallel lines. You have 3 to try. Make sure that when you do, don't just give me the answer for the angle measure, but give me the justification. So you're going to name the theorem or the postulate that allows you to do what you're doing with those problems. Give them a shot.